What if everything we believe about human history is wrong? Human civilization is only about 6,000 years old, but Earth is 4.5 billion years old. That leaves an unimaginable amount of time before us. Now imagine this. What if millions of years ago, another intelligent species built cities, developed advanced technology, and completely disappeared? Some scientists have even explored this idea through the Silurian Hypothesis, asking a disturbing question: if a technological civilization existed millions of years before humans, would we even be able to detect it today? Could ancient ruins be buried deep beneath Earth's crust, erased by time itself? Or are we truly the first advanced civilization to ever walk this planet? Imagine standing at the edge of a cliff, looking out over a vast ocean. The horizon stretches endlessly before you, and for a moment, you feel like you're at the edge of everything, the boundary of the known world. Now imagine that feeling, but applied not to space, but to time. What if the world you think you know, the history you've been taught, the timeline of human civilization you've accepted as settled fact, what if all of it were only a fraction of the real story? What if buried beneath the layers of geological time, hidden under the sands of ancient deserts, drowned beneath rising seas, and swallowed by the voracious appetite of entropy, there was a civilization, or perhaps many civilizations, that rose to heights of sophistication long before any history book dares to suggest? This is not a fringe question reserved for conspiracy theorists and late-night talk radio. This is a question being asked, quietly, carefully, sometimes controversially, by geologists, archaeologists, astronomers, physicists, and philosophers. It is a question that cuts to the heart of who we are, where we came from, and whether the story of human civilization we've constructed is more like a chapter in a much longer book than the whole story itself. Today, we are going to explore that question fully and seriously. We are going to walk through the evidence, geological, archaeological, astronomical, biological, and theoretical. And we are going to ask ourselves honestly, what would a prior advanced civilization on Earth actually look like? Would we recognize it if we found it? And perhaps most disturbingly of all, have we already found it and simply refused to understand what we were looking at? The problem with our timeline. To understand why this question even arises, we first need to understand what our conventional historical timeline actually looks like. And more importantly, we need to understand its limitations. The standard model of human history goes something like this. Modern humans, Homo sapiens, emerged roughly 300,000 years ago in Africa. For the vast majority of that time, our ancestors lived as hunter-gatherers, nomadic bands of people who survived by following animal migrations, harvesting wild plants, and slowly developing tools, language, and culture. Then, approximately 12,000 years ago, something extraordinary happened. In the region of the world we call the Fertile Crescent, modern-day Iraq, Syria, Turkey, and Iran, humans began to settle down. They learned to cultivate crops, to domesticate animals, to build permanent structures. They developed writing, mathematics, astronomy, and law. Civilization, as we understand it, was born. From that point, the narrative moves quickly and confidently. Sumer, Babylon, Egypt, the Indus Valley, the Shang dynasty, Greece, Rome, the Islamic Golden Age, the Renaissance, the Industrial Revolution, and then us. The technological civilization of the 21st century. It's a clean, linear story of progress. Primitive to sophisticated, chaos to order, stone tools to smartphones. But here's where we have to pause and ask some very hard questions. How solid is this timeline, really? How much of human history have we actually uncovered versus how much remains buried, eroded, destroyed, or simply unknown? The answer, when you look at it honestly, is deeply humbling. Archaeologists estimate that we have excavated only a tiny fraction of the total potential archaeological record. The vast majority of ancient sites have never been found, and a significant portion of those that have been identified have never been meaningfully excavated. Funding is limited. Access is restricted, political instability prevents fieldwork, and the sheer scale of the Earth makes systematic searching impossible with current technology. Furthermore, and this is crucial, We know that large portions of the Earth's surface where ancient people could have lived are now completely inaccessible. During the last ice age, which peaked around 20,000 years ago and ended roughly 11,700 years ago, global sea levels were dramatically lower than today. We're talking about sea levels that were, in some regions, more than 120 meters, nearly 400 feet, lower than they are now. That means enormous swaths of continental shelves that are today submerged under shallow coastal seas were once dry land. In fact, the total land mass available to humans during the Ice Age was significantly larger than it is today. Think about what that means. All the coastlines, river valleys, and plains that early humans might have inhabited, built upon, and cultivated, all those areas are now sitting at the bottom of the ocean. The Persian Gulf, for much of the last glacial period, was largely dry land, a fertile river valley fed by the Tigris, Euphrates, Karun, and Wadi Batin rivers. The area around Indonesia, Australia, and Southeast Asia was connected in ways that no longer exist. A massive stretch of land connected Britain to continental Europe. Parts of the Bering Sea were dry land. Hundreds of thousands of square miles of potentially habitable and potentially inhabited territory now lie underwater, in some cases dozens or hundreds of meters deep. And yet, this is where most of our assumptions about ancient human life are built. On land, on what remains above the waterline. We have constructed an entire model of human prehistory based on the fraction of the ancient world that happened to survive geological and climatic change, and we have treated that fraction as if it were the whole. This is not a minor gap in our knowledge, it is a profound, gaping void. And into that void, the question of prior advanced civilization rushes with alarming urgency. The Silurian Hypothesis and what science actually says. In 2018, two scientists, Gavin Schmidt, director of NASA's Goddard Institute for Space Studies, and Adam Frank, an astrophysicist at the University of Rochester, published a paper in the peer-reviewed journal International Journal of Astrobiology. The paper was titled The Silurian Hypothesis: Would it be possible to detect an industrial civilization in the geological record? The name comes from a Doctor Who episode, but the question the paper asks is entirely serious. If a technologically advanced civilization had existed on Earth millions of years before us, not necessarily human, but perhaps another species, or an earlier branch of our own genus, what traces would it leave behind that would still be detectable today? The conclusions of Schmidt and Frank are remarkable and unsettling. They found that the geological record would be a very poor archive of industrial civilization. Most of the physical artifacts of an advanced society, buildings, roads, machines, tools, electronic devices, would simply not survive over millions of years. Stone degrades, metal corrodes, plastic, for all its persistence by human timescales, would fragment and chemically alter over geological time. An entire civilization that lasted even 1,000,000 years might leave almost no physical trace visible to geologists 10 million years later. What might survive, they found, are chemical anomalies. Specifically, an industrial civilization would likely alter the ratios of carbon isotopes in sedimentary rock, produce unusual concentrations of certain metals like platinum, palladium, and rare earth elements in geological strata, and potentially leave traces in the nitrogen cycle. Some of these anomalies might resemble natural events closely enough to be misidentified, or might be so subtle that they would only be recognized if researchers were specifically looking for them. Schmidt and Frank were careful to note that they were not claiming a prior civilization existed. What they were saying is far more thought-provoking. We probably wouldn't be able to tell if one had. Our geological tools are simply not calibrated to detect the chemical fingerprint of a civilization at the scale we would need to find it. We have been looking at the rock record through a framework designed to identify natural geological processes, not industrial ones. This is a legitimate scientific paper written by credentialed scientists at respected institutions, raising a legitimate scientific question. The Silurian Hypothesis is not pseudoscience. It is a serious exercise in epistemological humility, an acknowledgement that our knowledge of deep time is far from complete, and that our instruments for reading that deep time are limited in ways we don't always appreciate. Now, Schmidt and Frank were primarily thinking about non-human industrial civilizations that might have existed tens or hundreds of millions of years ago, in the age of dinosaurs, for example, or even further back, but the same logic applies to our own species and our near relatives. If there had been a technologically sophisticated human or human-adjacent civilization even 100,000 years ago, let alone a million years ago, what evidence would remain? The answer is probably very little, and possibly nothing that we would currently recognize as such. The archaeological anomalies we keep finding. But here's the thing, we are finding things. We keep finding things that don't fit the standard model. Not aliens, not magic, not supernatural intervention, but evidence of human activity, human sophistication, and human complexity that pushes against the edges of the accepted timeline in ways that mainstream archaeology is only slowly beginning to reckon with. Let's start with Göbekli Tepe, because it is perhaps the single most disruptive archaeological discovery of the last century. Located in southeastern Turkey, near the ancient city of Şanlıurfa, Göbekli Tepe is a series of massive stone enclosures built on top of a hill. The site was excavated beginning in the 1990s by German archaeologist Klaus Schmidt, and what he found there upended decades of archaeological consensus. The structures at Göbekli Tepe consist of large T-shaped limestone pillars, some of them standing more than 5 meters tall and weighing up to 10 tons, arranged in circular patterns and covered with elaborate carvings of animals: foxes, snakes, boars, birds, and other creatures. The level of artistic sophistication and engineering precision required to create these structures is extraordinary. The pillars had to be quarried from limestone bedrock, shaped, transported, and erected with tremendous skill and coordination. And here is the part that changed everything. Göbekli Tepe has been dated to approximately 11,600 years ago, which means it was built at the very beginning of the Neolithic period, if not before it. It predates Stonehenge by more than 6,000 years. It predates the Great Pyramid of Giza by more than 7,000 years. It was built before pottery, before the plow, before writing, according to our standard model, by people who were just barely transitioning out of a nomadic hunter-gatherer lifestyle. This should be impossible. The construction of Göbekli Tepe would require a sophisticated social organization, a specialized labor force, a concept of monumental architecture, a religious or cosmological framework that motivated thousands of hours of collective work and the engineering knowledge to realize it. None of these things should exist, according to the standard model, in 9600 BCE. Klaus Schmidt himself said, before his death in 2014, that Göbekli Tepe suggested that civilization did not lead to the creation of ritual and religious spaces. Rather, the need to build ritual and religious spaces may have led to civilization. In other words, the standard model might have the order of causation exactly backwards. The question this raises is obvious. If the capacity for this level of sophistication existed 11,600 years ago, what might have existed 20,000 years ago or 50,000 years ago, and why don't we have evidence of it? One possible answer is that we haven't been looking hard enough or in the right places. Another possible answer is that the evidence existed but has been destroyed by time. And a third, more radical possibility is that something catastrophic happened that reset human civilization, not once, but possibly multiple times. The mystery of underwater ruins. Let's return to the ocean, because the sea is hiding secrets that may be more significant than anything we've found on land. Off the coast of Japan, near the island of Yonaguni, lies one of the most controversial underwater structures on Earth. The Yonaguni Monument is a series of massive stone formations sitting about 25 meters below the surface of the ocean. The structures feature flat terraces, right angles, sharp edges, and what appear to be staircase-like formations cut into the rock. The main formation is roughly 60 meters wide, 30 meters long, and 8 meters high. The debate over Yonaguni is fierce. Some geologists argue that the formations are entirely natural, the product of a specific type of sandstone that tends to fracture along horizontal and vertical planes, creating geometric shapes through natural processes. Others, including Masaki Kimura, a marine geologist at the University of the Ryukyus who spent years diving at the site, argue that the precision of the angles, the presence of what appear to be carved channels and holes, and the overall layout of the structures strongly suggest human modification, if not outright human construction. What is not in dispute is the timing. Yonaguni is at a depth that would place it above sea level during the last ice age, specifically during the period roughly 10,000 to 12,000 years ago, when sea levels were still significantly lower. If any part of the Yonaguni monument is human-made, it would have been built or modified during that period, again, pushing the timeline of sophisticated construction back beyond what the standard model allows. Yonaguni is not alone. Off the coast of India, in the Gulf of Khambhat, formerly called the Gulf of Cambay, marine archaeologists discovered in 2001 what appears to be a submerged city. The site, found using sonar imaging, appears to show geometric structures, roads, and artifacts at a depth of about 40 meters. The National Institute of Ocean Technology in India pulled up artifacts from the site, including wood samples that were dated to approximately 9,500 years ago. If confirmed, this would make the Gulf of Khambhat site older than any known civilization in the Indian subcontinent, older even than the famous Indus Valley civilization, and it would be sitting underwater. In the waters around Cuba, near the western tip of the island, a Canadian exploration company called Advanced Digital Communications reported in 2001 that they had detected unusual stone formations at a depth of 600 to 750 meters using sonar. The formations appeared to show grid-like street patterns, pyramidal structures, and geometric shapes. Follow-up dives with remotely operated vehicles produced video footage that some researchers found compelling, but the site has never been fully excavated or conclusively explained. The depth is puzzling. 600 meters is far deeper than could be explained by simple Ice Age sea level changes, which either means the structures are natural or that something more dramatic occurred to cause that land to subside to such depths. In the waters off the coast of Malta, near the island of Filfla, researchers have documented a series of cart ruts, the same strange, deeply grooved parallel tracks found abundantly on Malta itself, that continue directly off the cliff edge and into the sea. The land-based cart ruts are one of Malta's great unsolved mysteries. They appear to predate the famous megalithic temples of Malta, which are themselves among the oldest freestanding stone structures in the world. The fact that they run off the coastline into the sea strongly suggests that they were made when the land extended further than it does today, during a period of lower sea levels. Whatever civilization made those ruts was operating in an era that archaeology has largely left unexplored. The pattern, when you look at it globally, is striking. Around the world, in coastal waters that were once dry land, there are hints, suggestions, and in some cases fairly clear evidence of human activity that predates our accepted timeline for sophisticated civilization. The ocean has been rising steadily since the end of the last ice age, and it has been swallowing the most accessible, most fertile, most desirable human habitats as it rose. The fact that we have found so little underwater is not necessarily evidence that nothing was there. It may simply be evidence of how little we've looked. The Younger Dryas impact hypothesis and the Great Reset. Now we need to talk about something that may be the most important geological event in the history of human civilization, and until recently, we had almost no idea it happened. The Younger Dryas was a period of dramatic, rapid climate cooling that occurred roughly 12,900 years ago. After thousands of years of warming as the last ice age was ending, temperatures suddenly plummeted, in some regions by as much as 10 to 15 degrees Celsius within just a century or two. Ice sheets re-expanded, glaciers advanced, sea levels, which had been rising, temporarily stabilized. The warm, hopeful interglacial period that was beginning came to an abrupt halt, and Earth was plunged back into near-glacial conditions for about 1,200 years before warming resumed just as suddenly around 11,700 years ago. For decades, scientists debated what caused the Younger Dryas. The leading hypothesis was the meltwater pulse theory, the idea that a massive influx of cold fresh water from melting glaciers into the North Atlantic disrupted ocean circulation patterns, triggering the cooling event. This is a reasonable hypothesis, but the mechanism is complex and the evidence incomplete. Then, in 2007, a team of researchers published a paper proposing a radically different explanation. They argued that the Younger Dryas was triggered by a cosmic impact, specifically by the breakup and collision of a comet or asteroid that struck the North American ice sheet approximately 12,900 years ago. The Younger Dryas impact hypothesis, as it came to be known, suggested that this impact event caused catastrophic fires across North America and other parts of the world, destabilized the ice sheets, disrupted climate systems, and led to the extinction of the large mammals, the mammoths, mastodons, giant ground sloths, and others that had roamed North America for tens of thousands of years. The hypothesis has been fiercely debated ever since. Critics raised serious objections, proponents gathered more evidence. And over the course of more than 15 years of research, the evidence for some kind of cosmic impact event at the Younger Dryas boundary has grown substantially. Researchers have found a thin layer of sediment in sites around the world, in North America, Europe, the Middle East, and elsewhere, that dates to approximately 12,900 years ago and contains a suite of markers associated with high-temperature cosmic impact events. These include nanodiamonds, which can form under the extreme pressure of impact events. They include spherules, tiny spherical particles of glass and metal formed when rock and ice are vaporized and then cooled rapidly. They include elevated concentrations of platinum, iridium, and other platinum group elements that are rare in the Earth's crust, but more common in meteorites and comets. They include high concentrations of soot, consistent with global wildfires. And they include a specific type of carbon called lonsdaleite, a hexagonal form of diamond that has so far only been confirmed to form in the extreme heat and pressure of an impact event or a meteorite itself. The geographic spread of this impact layer is enormous. It has been identified in sites from California to South Carolina, from the Netherlands to Syria, from South Africa to Chile. If this evidence is genuine, and a growing body of peer-reviewed research suggests it is, then something extraordinary and catastrophic happened 12,900 years ago. Something that burned much of North America's forests, may have destabilized and fragmented a comet or asteroid large enough to alter the global climate and plunge civilization, such as it was, into more than a millennium of cold, instability, and crisis. Now here is where this connects to our central question. If there were sophisticated human societies existing in the millennia before 12,900 years ago, during the warming period that preceded the Younger Dryas, those societies would have been concentrated along the coastlines and river valleys that offered the most resources. They would have been precisely the people most vulnerable to a catastrophic impact event, to the wildfires that followed, to the sea level changes and climate disruptions that reshaped the world. And after 200 years of cold and instability, whatever they had built could have been largely or entirely erased. The population of humans on Earth at that time was small, perhaps 5 to 10 million total. A catastrophic event that killed a large fraction of that population, destroyed their settlements, and forced the survivors back to a more basic mode of subsistence would leave almost nothing in the archaeological record. The survivors would be rebuilding from scratch or near scratch, and they would almost certainly have lost most of the knowledge and technology that characterized whatever more sophisticated culture had come before. Memory would persist only in oral tradition, in myths, in stories, in the kind of fragmentary cultural memory that later civilizations would encode in flood myths, stories of fallen golden ages, and tales of great cataclysms visited on proud and powerful civilizations by the gods. The flood myths of every culture. Speaking of flood myths, let's talk about them, because they are one of the most striking cultural universals in human history. Virtually every major culture on Earth has a flood myth. The story almost always follows the same basic pattern. A great civilization or a favored people exists. They become corrupt or complacent. The gods, or God, or the forces of nature send a catastrophic flood that destroys nearly everything. A small number of survivors, usually a single family or a small group guided by divine warning, survive on a boat or some high place. And from those survivors, the world is repopulated and civilization is rebuilt. The most famous version in the Western tradition is, of course, the story of Noah and the Ark from the Hebrew Bible. But the Noah story itself is clearly derived from far older Mesopotamian texts. The Epic of Gilgamesh, one of the oldest surviving works of literature in the world, contains a flood narrative featuring a character named Utnapishtim, who is almost identical to Noah. Warned by the god Ea, he builds a great boat, loads it with animals and people, survives a catastrophic flood, and is eventually granted immortality by the gods. The parallels between the Gilgamesh flood story and the Noah story are so close that many scholars believe they share a common origin. But the flood myth extends far beyond the Middle East. In Hindu tradition, the god Vishnu appeared as a fish to warn the ancient sage Manu of an impending flood, instructing him to build a boat and fill it with the seeds of all living things. In Aztec tradition, the god Tlaloc sent a great flood to destroy the Second World, and a man named Coxcox and his wife survived by hiding in a cypress tree. In the mythology of the Hopi people of North America, the Third World was destroyed by a great flood, and the survivors were guided to the Fourth World through hollow reeds. In Chinese mythology, a great flood covered the earth and was eventually controlled by the hero Gun and his son Yu. In ancient Greek mythology, Zeus sent a flood to destroy humanity, and only Deucalion and his wife Pyrrha survived, building a boat and later repopulating the earth by throwing stones over their shoulders. The question is, why? Why does virtually every culture on Earth independently develop a story about a catastrophic flood that nearly destroyed all of humanity? There are a few possible explanations. One explanation is psychological, that flood myths reflect a universal human anxiety about the destructive power of water, and that they serve as morality tales about the dangers of pride and corruption. This is a reasonable explanation, but it struggles to account for the specific and consistent details across cultures: the warning, the boat, the animals, the survival of a small group, the rainbow or divine sign at the end. Another explanation is historical, that all these myths share a common origin in actual events, specifically the rapid flooding of the Mediterranean basin, the Black Sea, the Persian Gulf, and other coastal regions as glaciers melted and sea levels rose at the end of the last ice age. People who lived along these coastlines would have experienced genuine, terrifying floods, not the gradual millennial creep of sea level rise we're familiar with, but rapid, catastrophic inundations of land that happened within human lifetimes or even within a single generation. The Black Sea flooding hypothesis, first proposed in detail by geologists William Ryan and Walter Pittman in 1997, suggests that around 7,600 years ago, rising Mediterranean sea levels breached a natural dam at the Bosporus and flooded the Black Sea basin, which at the time was a freshwater lake sitting at a lower elevation than the Mediterranean. The flood, Ryan and Pittman estimated, could have inundated the lake at a rate of perhaps 10 cubic miles of water per day, raising the water level by as much as 6 inches per day. Any communities living around the shores of the Black Sea, and there were many as the warm, fertile basin was a desirable place to live, would have experienced a catastrophic, rapid, irresistible flooding of their homeland. These people would have become refugees, carrying their story of a great flood with them as they dispersed across the Middle East and into Europe, seeding the cultural memory that eventually became the flood myths we know today. The Black Sea flood hypothesis is compelling but contested. What is less contested is that the end of the Ice Age was a period of dramatic, repeated, and in some cases, catastrophic sea level changes that would have had profound impacts on human populations. And if those human populations were more sophisticated than we've given them credit for, if they had settlements, agriculture, writing, or other advanced technologies that we haven't yet found, then the loss of their coastal civilizations to rising seas would explain both the fragmentary nature of the archaeological record and the universal cultural memory of a world-ending flood. Ancient astronomical knowledge. Here is another piece of the puzzle that doesn't fit comfortably into the standard timeline: the astronomical knowledge embedded in ancient structures and myths. We know that many ancient monuments around the world are precisely aligned with astronomical phenomena. Stonehenge is aligned with the summer solstice sunrise. The Great Pyramid of Giza is aligned with cardinal directions with a precision of less than 1/10 of a degree, a feat of surveying that would be impressive with modern instruments. The temples of ancient Egypt were often aligned so that sunlight would illuminate the inner sanctuary on specific astronomical dates. The Caracol Tower at Chichen Itza in Mexico was designed to observe Venus at specific points in its cycle. The ancient stone circles of the British Isles, the temples of Angkor Wat in Cambodia, the medicine wheels of the North American plains all show sophisticated astronomical knowledge encoded in their design. But some researchers have argued that the astronomical alignment of ancient monuments goes even deeper than solar and lunar observations. They have argued that some ancient structures encode a knowledge of precession, the slow, 26,000-year wobble of the Earth's rotational axis that causes the apparent position of the stars to shift slowly over millennia. Precession is the reason why the zodiacal constellations gradually change their relationship to the seasons over thousands of years. The ancient Egyptian concept of the Great Year, a full cycle of precession, was apparently known and incorporated into religious cosmology. The Sphinx, some researchers argue, was built to face directly east, aligning with the rising sun at the spring equinox, but its leonine shape would have been most symbolically resonant when the spring equinox sunrise occurred in the constellation of Leo, which happened not in the historical period of ancient Egypt, but around 10,500 to 8,000 BCE. If this astronomical alignment was intentional, it suggests that either the Sphinx is far older than mainstream Egyptology accepts, or that the people who designed it had access to knowledge of a much earlier astronomical configuration. The precession hypothesis is controversial, and most Egyptologists reject it. But the broader point stands. The level of astronomical knowledge encoded in ancient monuments around the world is surprisingly advanced for cultures that supposedly had no telescopes, no written mathematics, and no long tradition of recorded observation. Where did this knowledge come from? One possibility, explored seriously by researchers like Graham Hancock and Randall Carlson, is that it represents inherited knowledge, the distilled astronomical observations of a much older civilization, preserved and transmitted across generations in myth, architecture, and sacred tradition, even as the civilization that originally developed it was lost to catastrophe. This is a speculative hypothesis, but it is not an irrational one. We know that complex technical knowledge can be encoded in oral tradition and transmitted remarkably accurately across many generations. The question is whether the astronomical sophistication of the ancient world points to a longer history of observation than we've accounted for. The Antikythera mechanism and the problem of ancient technology. In 1901, sponge divers off the coast of the Greek island of Antikythera discovered the wreck of an ancient ship. Among the artifacts they brought up from the seafloor was a lump of corroded bronze that looked like a rock. It wasn't. It was, as subsequent analysis would reveal, one of the most extraordinary objects ever found, an intricate mechanical device of staggering complexity. The Antikythera mechanism, as it came to be known, is a geared computing device built sometime between 200 and 60 BCE. When scholars finally succeeded in understanding its function, using X-ray tomography and other modern imaging techniques, they found that it was an astronomical calculator of remarkable sophistication. It could predict the positions of the sun and moon, calculate solar and lunar eclipses, track the cycle of the ancient Olympic Games, and display the movements of the known planets, all through a complex system of bronze gears operating at different ratios. Nothing remotely like the Antikythera mechanism appears in the archaeological record until the medieval clockwork of 14th century Europe. A gap of more than 1,000 years. Its level of mechanical sophistication was not surpassed in Western technology until the late Middle Ages. Where did the knowledge to build it come from? How was such a complex device conceived, designed, and manufactured in the ancient world without any precursor technology? And perhaps most troubling of all, were there other devices like it that simply haven't survived? The Antikythera mechanism forces us to confront a deeply uncomfortable reality. Our picture of ancient technological capability is almost certainly incomplete. If a device of this sophistication existed in the ancient world and was almost entirely unknown to historians until its accidental discovery, it stands to reason that other examples of advanced ancient technology have been lost entirely, not preserved in any surviving form, leaving no trace whatsoever. This is not a theoretical concern. Consider how much technology from the ancient world has been lost permanently. Greek fire, the incendiary weapon used by the Byzantine Empire that could burn on water. The formula has never been rediscovered. The Romans developed a concrete for underwater construction that is, in some ways, more durable than modern concrete. For centuries, the formula was lost. Ancient metallurgists produced steel alloys, Damascus steel being the most famous, whose exact composition and manufacturing process remain incompletely understood. The color Tyrian purple, produced from sea snails and enormously valuable in the ancient world, was lost as a manufacturing process for more than 1,000 years. If technologies this sophisticated could be lost in historical times, in the well-documented eras of Rome, Byzantium, and the medieval Islamic world, how much more could have been lost in prehistory when there was no writing, no institutional continuity, no libraries or universities to preserve knowledge across generations? The genetic evidence. Now let's add another layer of complexity to this picture: genetics. Over the past 2 decades, the study of ancient DNA has revolutionized our understanding of human prehistory. By extracting and sequencing the genetic material from ancient human remains, scientists can now trace the movements, relationships, and histories of ancient populations with an accuracy that was impossible just a generation ago. And what ancient DNA has revealed is a world far more complex, far more turbulent, and far more surprising than the neat, linear story we thought we knew. We now know, for example, that modern humans did not simply spread out of Africa and gradually replace other hominin species. Instead, modern humans interbred with multiple other hominin species, Neanderthals, Denisovans, and at least one other unidentified hominin group, sometimes called the ghost population. Most non-African humans today carry a small but significant percentage of Neanderthal DNA. Many people from Southeast Asia and the Pacific carry Denisovan DNA. And some populations in Africa carry genetic markers from a mysterious hominin group that has never been definitively identified in the fossil record. What this tells us is that the human story was messier, more complex, and more interesting than we imagined. Multiple intelligent, tool-using, linguistically capable species were living on Earth simultaneously. They were encountering each other, sometimes competing, sometimes cooperating, and apparently, sometimes interbreeding. The idea of a single, linear progression from primitive to sophisticated is a myth. The reality was a world of multiple lineages, multiple experiments, multiple trajectories of development, all happening simultaneously. Ancient DNA has also revealed dramatic and rapid population replacements. We now know that the people who built Stonehenge were almost entirely replaced by newcomers from the Pontic Steppe, the grasslands north of the Black Sea, around 4,500 years ago. In just a few generations, the population of Britain changed almost entirely. The people who built Avebury and Stonehenge, one of the most remarkable architectural traditions in prehistoric Europe, essentially vanished. Their descendants contributed only a tiny fraction to the genetic profile of later British populations. This pattern of replacement, of entire populations being displaced, absorbed, or destroyed in relatively short periods, is repeated across ancient DNA studies from around the world. It suggests a prehistoric world of far more dramatic upheaval than we typically imagine, and it raises a profound question: how many civilizations, how many sophisticated cultures, how many advanced traditions of knowledge and technology were simply exterminated or absorbed before they could leave any lasting trace? There's also something geneticists call a population bottleneck, a period during which the total human population was reduced to a very small number, creating a narrow genetic bottleneck that left its signature in modern human DNA. There is evidence in modern human genetics of at least one severe bottleneck, and possibly more, in the ancient past. Some researchers have proposed that a massive volcanic eruption, the Toba supereruption of approximately 74,000 years ago, may have reduced the global human population to as few as a few thousand individuals, creating a genetic bottleneck that is still visible in modern human DNA. If the total human population was reduced to thousands of individuals even once in our history, the implications for any prior sophisticated civilization are obvious. Whatever they had built, whatever they had learned, whatever technology or knowledge they had developed, almost all of it would have been lost. The survivors would have been, by definition, those lucky enough to be in the right place at the right time, and they would be struggling simply to survive. Civilization would have had to start over, not from zero perhaps, but from a point far earlier on the developmental curve. What would an advanced prehistoric civilization actually look like? Let's pause here and think carefully about a fundamental assumption we've been making. When we imagine an advanced civilization, we almost inevitably imagine something that looks like our own civilization. Cities of steel and glass, electrical grids, industrial manufacturing, computers, automobiles. We project our own technological trajectory onto the past and then go looking for evidence of it. But what if a prior advanced civilization looked nothing like ours? Human technological development is not predetermined. There is no fixed path from primitive to advanced that every civilization must follow. Our particular technological trajectory, fossil fuels, electricity, digital computing, is just one of an enormous number of possible trajectories. A civilization that developed along different lines might have achieved a comparable level of sophistication in ways that left completely different archaeological footprints, or in some cases, footprints that we would struggle to recognize as technological at all. Consider a civilization that achieved sophistication through biological rather than mechanical means, through the mastery of genetic modification, selective breeding, or biological engineering, might have built nothing that modern archaeologists would recognize as a structure or a tool. Everything it built might have been organic, biodegradable, and gone without a trace. A civilization that achieved sophisticated communication through social and cultural means, through perfected oral tradition, complex body language, or other non-material channels, might have left no physical record at all. A civilization that developed advanced knowledge of ecology, agriculture, and pharmacology, that understood how to cultivate and manage landscapes, how to produce complex medicines from plants, how to optimize food production without mechanical tools, might have left a mark on the genetic history of domesticated plants and animals, but almost nothing in stone or metal. It is worth remembering that the most sophisticated things human beings have ever produced are not physical objects. They are ideas, mathematics, philosophy, music, language. These are the most complex and powerful products of human intelligence, and they leave almost no direct physical trace. If an ancient civilization's greatest achievements were intellectual or cultural rather than architectural or industrial, we would probably never know it existed. This is not an excuse to abandon the search for evidence or to accept speculation as fact. It is, rather, a call for humility about the limits of what the absence of evidence tells us. The absence of evidence is not evidence of absence, especially when we acknowledge how incomplete our search has been, how narrow our definition of evidence is, and how powerful the forces of geological time are in erasing the past. The oral traditions of indigenous peoples. There is a category of evidence that Western academic scholarship has historically dismissed or undervalued, but which is gaining increasing recognition as a serious source of historical information: the oral traditions of indigenous peoples around the world. Many indigenous cultures have oral traditions that encode information about geological and astronomical events with remarkable accuracy. Researchers studying these traditions have found detailed accounts of events, volcanic eruptions, earthquakes, tsunamis, sea level changes, that correspond to verifiable geological records with sufficient accuracy to suggest the traditions have been preserved over thousands, and in some cases, tens of thousands of years. Australian Aboriginal oral traditions, for example, contain detailed accounts of sea level rise and the flooding of coastal lands. In 2015, a study published in the journal Australian Geographer documented multiple Aboriginal traditions describing the flooding of land that is now submerged under the sea, and matched these traditions to specific geographical features whose submergence can be dated by sea level records. Some of these traditions appeared to describe events that occurred 7,000 to 10,000 years ago, representing a continuous, accurate oral record spanning more than 300 generations. This is extraordinary. If oral tradition can reliably preserve detailed geographical knowledge across 10,000 years, it can certainly preserve knowledge of civilizations and technologies that existed on similar timescales. The challenge is in decoding and interpreting those traditions, in distinguishing literal historical memory from metaphor, in identifying the real events behind the mythological framing. Many indigenous traditions around the world speak of great civilizations that preceded the current world, often described as more technologically or spiritually advanced than the present world, which is typically portrayed as a degraded version of a more perfect original. The Hindu concept of the yugas, cosmic cycles of decline from a golden age to a progressively more degraded present. The Aztec concept of 5 successive worlds, each destroyed by a different catastrophe. The Hopi concept of 3 previous worlds destroyed by fire, ice, and flood. The Greek concept of the ages of gold, silver, bronze, and iron all encode the same fundamental narrative. We are not the first, and we are not the greatest. Now, these traditions could be entirely mythological, reflections of human psychology, of our tendency to idealize the past and denigrate the present, of our need for origin stories that lend meaning to our existence. That is the default interpretation of mainstream academia. But what if they're not entirely mythological? What if they encode real historical memory, filtered through thousands of years of oral transmission and mythological elaboration, but rooted in actual events, in the existence of actual prior civilizations that were destroyed by actual catastrophes? The possibility deserves serious consideration, not credulous acceptance, but serious, rigorous investigation. The same rigor we would apply to any historical source, with appropriate allowances for the form of transmission. The mystery of the pyramids, reconsidered. No discussion of the possibility of prior advanced civilization can avoid the pyramids. They are the most dramatic and enduring physical evidence of ancient sophistication, and they continue to generate controversy, wonder, and genuine scientific puzzlement. Let's be clear about what the pyramids actually are, without either the breathless mystification of alternative history enthusiasts or the dismissive overconfidence of some mainstream archaeologists. The Great Pyramid of Giza is, by any reasonable measure, one of the most extraordinary physical achievements in human history. It consists of approximately 2.3 million stone blocks, with an average weight of 2.5 to 15 tons each. The largest blocks in the King's Chamber weigh up to 80 tons. The pyramid's base covers 13 acres and is level to within 2.1 centimeters. Its sides are aligned with true north, south, east, and west, with a precision of less than 1/20th of a degree. Its total mass is estimated at about 5.9 million tons. How was it built? Mainstream Egyptology's answer is essentially by thousands of well-organized, well-fed workers using copper tools, wooden sledges, ramps, and the organizational genius of a sophisticated bureaucratic state. This answer is plausible, and there is genuine archaeological evidence supporting it. Workers' villages have been found near Giza. Graffiti left by work gangs has been discovered in the internal chambers. Papyrus records from ancient Egypt describe the logistics of quarrying and transporting stone. The mainstream explanation is not obviously wrong, but it is also not without serious difficulties. The precision of the Great Pyramid's construction remains genuinely puzzling. The tolerances involved in fitting millions of stone blocks together, many of them weighing several tons, with joints tight enough to not admit a piece of paper. This is a standard of precision that modern engineers find impressive even with modern tools. The alignment with true north, achieved without magnetic compasses, which weren't invented yet, and in a time when the North Pole star was a different star than it is today, required astronomical observation techniques of considerable sophistication. Then there's the question of the internal chambers. The shafts leading from the King's Chamber and the Queen's Chamber are precisely angled to point toward specific stars at specific times. In the case of the King's Chamber, toward the belt of Orion and the star Thuban, which was the pole star at the time of the pyramid's construction. The precision of these astronomical alignments is remarkable and suggests that the pyramid was conceived as an astronomical instrument of considerable sophistication, not merely a tomb. There is also the unresolved question of the Sphinx. Geologist Robert Schuck of Boston University has argued, based on the pattern of weathering visible on the Sphinx enclosure walls, that the Sphinx shows evidence of heavy rain weathering, the kind of erosion caused by long exposure to significant rainfall. The problem is that Egypt has been essentially arid for at least 5,000 years. Significant rainfall in that region would require a much older date, perhaps 7,000 to 10,000 years ago. If Schuck's interpretation is correct, the Sphinx was built during the African humid period, when the Sahara was much wetter and greener than it is today, and the Nile civilization we know as ancient Egypt was thousands of years in the future. Schuck's claim has been rejected by most Egyptologists, who argue that the weathering patterns he identifies can be explained by wind erosion, salt weathering, or other geological processes that don't require rain. The debate continues, and it is a genuine scientific debate, not a pseudo-scientific fringe argument, but a disagreement between qualified researchers about the interpretation of physical evidence. The broader point about the pyramids is this: they represent a level of mathematical, astronomical, and engineering knowledge that seems, to many observers, disproportionate to the supposed state of Egyptian civilization at the time they were built. This doesn't require aliens, and it doesn't require magic. It might simply require a longer history of knowledge development than we've accounted for, a history that stretches back into the pre-catastrophe world, preserved and transmitted across generations in forms we haven't yet fully understood. The Piri Reis map and the problem of ancient cartography. In 1929, historians working in the Topkapi Palace in Istanbul discovered a map drawn on gazelle skin. It was dated to 1513 CE, and it was made by an Ottoman admiral named Piri Reis, who noted in his own annotations that the map was compiled from much older source charts, including, he claimed, charts that had been used by Christopher Columbus. The map shows the coastlines of South America and Africa with considerable accuracy, more accuracy in some respects than maps produced by European cartographers for another century or more. But the truly astonishing thing about the Piri Reis map, and the thing that has made it a subject of intense and continuing controversy, is this: the lower portion of the map appears to show a coastline that corresponds in some features to the coastline of Antarctica. Specifically, to the coastline of Antarctica as it appears under the ice, as revealed by modern geophysical surveys. Antarctica was not officially discovered by Europeans until 1820. The Antarctic ice sheet has covered most of the continent's coastline for at least 6,000 years, and possibly much longer. If the Piri Reis map genuinely shows the ice-free coastline of Antarctica, it would require the existence of source charts compiled at a time when Antarctica's coast was accessible, at minimum thousands of years before the map was made. How those charts could have existed and been preserved until the 16th century is a question that has no accepted answer. The Piri Reis map interpretation is contested. Many scholars argue that what looks like Antarctica is actually a distorted depiction of South America's southern tip, or a speculative southern continent included by the cartographer based on ancient Greek philosophical assumptions about a landmass in the far south. These are legitimate counter-arguments. The map's projection is unusual, its scale varies, and attributing specific coastline features to Antarctica requires some interpretive generosity. But the Piri Reis map does not stand alone. Other old maps, the Oronteus Phaneus map of 1532, the Boache map of 1737, also appear to show Antarctica, some with what look like ice-free coastlines, and all compiled from stated sources far older than their own dates. These maps collectively suggest that there may have been a cartographic tradition, drawing on very ancient sources, that preserved geographical knowledge of regions we believe were unknown to ancient peoples. Again, the conventional explanation is human error and interpretive pareidolia. The maps don't really show Antarctica, they show speculative southern continents, distorted projections, or garbled information about known southern regions. The unconventional explanation is that the maps reflect knowledge inherited from a civilization that was capable of global exploration and precise cartography in an era we have assigned to hunter-gatherers. Both explanations have adherents among serious researchers. The honest position is that the maps are genuinely strange, genuinely interesting, and genuinely unresolved. The Fermi paradox in reverse. Let's step back from Earth entirely for a moment and consider this question from a cosmic perspective, because it has implications that extend far beyond our own planet. The Fermi paradox is the famous observation attributed to physicist Enrico Fermi that given the age of the universe and the estimated number of stars capable of supporting habitable planets, the galaxy should be teeming with intelligent civilizations. Given the timescales involved, some of these civilizations should be millions or billions of years more advanced than we are, and yet we see no evidence of them. We hear no signals. We receive no visitors. The universe, as far as we can tell, is silent and empty of detectable intelligence. Where is everybody? There are many proposed solutions to the Fermi paradox, ranging from the disturbing, civilizations always destroy themselves before they can communicate across interstellar distances, to the hopeful, we're not looking in the right way, to the philosophical, perhaps intelligence doesn't inevitably lead to interstellar expansion. But let's consider the Fermi paradox in reverse, applied not to the galaxy, but to our own planet. Earth is approximately 4.5 billion years old. Life has existed on Earth for at least 3.5 billion years. Complex multicellular life has existed for approximately 600 million years. Intelligence, in the form of large brains, tool use, and complex social behavior, has existed in various forms for tens of millions of years across many lineages of birds and mammals. Modern humans, as a species, have existed for 300,000 years. Now here is the question, given the enormous span of time available, and given that intelligence has evolved multiple times in multiple lineages on this planet, how confident can we really be that sophisticated civilization has appeared only once in the last 12,000 years of a 4.5 billion year history? The Silurian Hypothesis, which we discussed earlier, raises exactly this question for non-human species. But we don't even need to reach that far back. Within the time frame of anatomically modern humans, 300,000 years, we are confidently claiming that sophisticated civilization appeared only in the last 4% of that time. Our species has been around for 300 millennia, and we're saying that nothing meaningful happened for the first 288,000 years. Is that credible? Is that plausible? Or is it simply an artifact of our failure to look? Our failure to look in the places where ancient civilizations might have flourished and been destroyed, our failure to interpret the evidence that's in front of us, and our institutional resistance to revising a historical narrative that has become deeply entrenched. The Earth Fermi paradox, if we can call it that, suggests that the complete absence of evidence for prior sophisticated human civilization on our own planet is about as suspicious as the complete absence of evidence for extraterrestrial civilizations in the broader galaxy. In both cases, the absence of evidence might reflect the genuine absence of the phenomenon, or it might reflect the limitations of our search. The mainstream archaeologists' objections and the honest responses. At this point, it is important to address the serious objections that mainstream archaeologists and geologists raise to the hypothesis of prior advanced civilization. These objections are not unreasonable, and they deserve honest engagement rather than dismissal. The first and most fundamental objection is what we might call the no smoking gun problem. Despite centuries of archaeological work, no one has found an ancient power plant, an ancient computer, an ancient radio transmitter, or any artifact unambiguously demonstrating industrial or post-industrial technology in a stratum that predates our accepted timeline by more than a few thousand years. The Antikythera mechanism is extraordinary, but it comes from a period within our accepted chronology. Göbekli Tepe is surprising, but it is a Stone Age site. It shows sophisticated organization and symbolic thinking, but not advanced technology in the modern sense. The absence of any hard evidence for prior advanced civilization is a genuine and powerful objection. The honest response to this objection is the one implicit in the Silurian hypothesis. We may simply not be able to find it. If an advanced civilization existed and was destroyed, and if sufficient geological time has passed, the physical evidence may be gone. The question then becomes, is the absence of evidence, given the limitations of our search and preservation, sufficient reason to dismiss the hypothesis entirely? Most scientists would say that the absence of positive evidence is not proof of non-existence, but it does mean the hypothesis must remain speculative until positive evidence is found. The second major objection is about population and resources. A sophisticated civilization requires a large population. There is a minimum threshold of people below which the kind of knowledge specialization, labor division, and cultural complexity that characterizes advanced civilization simply can't exist. The global human population 50,000 years ago was probably only a few 100,000 to a few million people. Could such a small population support a sophisticated civilization? The skeptics say no. The proponents of prior civilizations say that we're making assumptions based on our own civilization's model that may not apply universally. The third major objection is about the evolutionary timeline. The cognitive capabilities required for advanced civilization, symbolic thinking, language, mathematics, complex social organization, evolved gradually, and our best evidence suggests they were only fully in place in modern humans roughly 70,000 to 100,000 years ago. Before that, even anatomically modern humans seem to lack the full cognitive toolkit for civilization. This is a genuine constraint, though it still leaves tens of thousands of years of fully cognitively modern humans for which we have little archaeological explanation. The fourth objection is that many of the anomalous findings that alternative researchers cite as evidence of prior civilization have conventional explanations. Göbekli Tepe is surprising, but it can be explained within the framework of early Neolithic society. It didn't require anything beyond what hunter-gatherer societies were capable of. The Yonaguni monument has geological explanations. The Piri race map can be interpreted without recourse to ancient cartography. The weathering of the Sphinx can be attributed to Aeolian erosion. In each case, mainstream science has a conventional explanation that doesn't require a prior advanced civilization. The honest response here is to acknowledge that the conventional explanations are plausible, but not always compelling. Each individual anomaly can perhaps be explained away, but the cumulative weight of anomalies across geology, archaeology, mythology, genetics, and astronomy is harder to dismiss. The question is not whether any single piece of evidence proves a prior advanced civilization, but whether the totality of evidence makes the hypothesis more plausible than our current default assumption of complete prehistoric naivety. The philosophical implications. Let's move now from the evidential question to the philosophical one, because even if we can't definitively answer whether a prior advanced civilization existed, the implications of seriously entertaining the question are profound. The first and perhaps most important implication concerns our relationship to time. We live in a civilization that has a deeply peculiar relationship with history. We tend to think of history as a line, a continuous upward progression from primitive to sophisticated, from ignorance to knowledge, from chaos to order. We are the culmination of that progression, or at least the most recent and most impressive chapter in it. This is a deeply anthropocentric and even chronocentric view of our place in time, the assumption that we are, if not the end of history, at least the most significant point in it so far. The possibility of prior advanced civilization disrupts this assumption profoundly. If sophisticated civilization has arisen and collapsed before, once or multiple times, then we are not the culmination of an inevitable progress. We are a cycle, or perhaps an experiment. We are one iteration of something that may have been tried before, and the fact that prior iterations failed is, at minimum, a sobering warning about our own situation. There is a principle in philosophy and systems theory called ergodicity, the idea that in a sufficiently complex system over a sufficiently long time, any possible state will eventually be realized. Applied to civilization, this suggests that on a planet with intelligent life spanning hundreds of thousands of years, the emergence of sophisticated civilization is not a one-time event, but a recurring possibility. If the conditions for civilization can arise once, they can arise again, and if they can be destroyed once, they can be destroyed again. This perspective has immediate practical implications. We are currently facing a set of existential risks: climate change, nuclear weapons, artificial intelligence, pandemic disease, asteroid impact, that could, in the worst cases, destroy our civilization. The sobering possibility that prior civilizations have faced equivalent risks and failed should sharpen our sense of urgency about surviving our own existential challenges. We may not be the first species on this planet to build something remarkable and then watch it crumble, but we could, with sufficient wisdom and foresight, be the first to build something that lasts. The second philosophical implication concerns epistemology, the theory of knowledge and how we know what we know. The question of prior advanced civilization is fundamentally a question about the limits of human knowledge across deep time. It forces us to confront how much of our confidence in the standard historical narrative is based on genuine positive evidence and how much is based on the absence of contradictory evidence, which is, as we've seen, a much weaker form of justification. Epistemological humility of this kind is not a license for credulity or for accepting every alternative history theory at face value. It is, rather, a reminder that scientific knowledge is always provisional, always subject to revision in the light of new evidence, and that the more we know about the limits of our knowledge, the better scientists and thinkers we become. The third philosophical implication is perhaps the strangest and most vertiginous: the question of identity. If we are not the first advanced civilization on Earth, then the story of who we are changes fundamentally. We are not the pioneers of intelligence and technology on this planet. We are inheritors, whether we know it or not, of a much longer history. The myths we tell about our origins, the stories that shape our sense of who we are and where we come from, may be distorted echoes of a reality far more complex and far more ancient than we've imagined. This is unsettling. It is also, in a strange way, thrilling. It is an invitation to look at the world and our place in it with new eyes. What could we find in the next 50 years? We are living in a period of unprecedented technological capability for investigating the deep human past. Over the next 50 years, several technologies and methodologies have the potential to dramatically expand our knowledge and possibly resolve, once and for all, some of the questions we've been exploring. The first is deep ocean archaeology, the technology for exploring the continental shelves, the underwater lands that were above sea level during the Ice Age, is improving rapidly. Autonomous underwater vehicles, improved sonar systems, and advanced underwater excavation techniques are making it increasingly feasible to systematically survey the shallow seafloor for evidence of human habitation. We have already found suggestive evidence in several locations. A concerted, well-funded international effort to survey the world's continental shelves could, within decades, either confirm or definitively rule out the existence of significant pre-Ice Age human settlements in coastal areas. This is not a fringe project. Several mainstream archaeologists and oceanographers have been calling for increased attention to submerged landscapes, and some nations, particularly India and Japan, have made significant investments in underwater archaeology. The potential payoff in terms of historical knowledge is enormous. The second transformative technology is ancient DNA analysis. The field has already revolutionized our understanding of human prehistory in just a few decades, and it continues to advance rapidly. As the technology for extracting and sequencing ancient DNA improves, we will be able to analyze genetic material from increasingly ancient and degraded samples, from a wider range of environments, and from a broader geographic distribution than ever before. This will continue to reveal surprises about the complexity of ancient human populations and may eventually provide evidence of population groups or demographic patterns that point to levels of social organization and complexity we haven't accounted for. The third is LiDAR, light detection and ranging, the laser-based imaging technology that has already transformed archaeological survey in tropical regions. LiDAR can penetrate the dense forest canopy and reveal hidden structures on the ground beneath, producing detailed three-dimensional maps of landscapes that have never been directly explored. It has already led to the discovery of enormous, previously unknown ancient cities in Cambodia, Guatemala, and Bolivia. A systematic global LiDAR survey of tropical forests, mountainous regions, deserts, and other areas poorly covered by conventional archaeology would almost certainly reveal thousands of previously unknown sites, some of which might be far older or far more sophisticated than current models predict. The fourth is advances in geological dating techniques. Our ability to date ancient materials has improved dramatically with the development of techniques like optically stimulated luminescence dating, which can determine when sediment was last exposed to sunlight, and cosmogenic nuclide dating, which can date when rocks were last exposed to cosmic radiation. These techniques are pushing our ability to date ancient human activity further and further back in time and into environments where conventional dating methods can't be applied. As these techniques improve, we may find datable evidence of human activity in unexpected places and at unexpected depths of time. The fifth, and perhaps the most speculative but most potentially transformative, is the application of artificial intelligence to the analysis of geological, archaeological, and genetic data. AI systems capable of identifying subtle patterns in large, complex data sets could potentially find anomalies in the geological record that human researchers might overlook. Chemical signatures, structural features, or distributional patterns that are consistent with the Silurian Hypothesis or with other indicators of prior advanced civilization. The Silurian Hypothesis itself was, in a sense, an exercise in imagining what such a pattern search might reveal. Actual AI-assisted analysis of geological databases might take that exercise from the theoretical to the empirical. The responsibility of curiosity. As we approach the end of this exploration, it's worth reflecting on what kind of inquiry this is and how it should be conducted. The question of prior advanced civilization has too often been colonized by bad actors. There is a long and unfortunate history of the ancient mysteries narrative being weaponized to serve racist agendas, most notoriously in the Ancient Aliens framework, which implicitly argues that the architectural and intellectual achievements of non-white civilizations, Egypt, Mesoamerica, Sub-Saharan Africa, Southeast Asia, must have required outside intervention because those civilizations couldn't possibly have achieved such things on their own. This is not only scientifically bankrupt, it ignores the genuine genius and capability of the actual humans who built these monuments, but it is deeply offensive and harmful. The question of whether human civilization has a deeper and more complex history than we currently understand is a completely different question from whether ancient peoples needed alien help. The former is a legitimate and serious scientific inquiry. The latter is a racist fantasy dressed up in pseudo-scientific clothing. It is essential to keep these questions entirely separate. The legitimate version of this inquiry starts from a position of profound respect for the capabilities of ancient humans. Our ancestors were not less intelligent than we are. Their brains were identical to ours. Their cognitive capabilities, their capacity for symbolic thinking, mathematical reasoning, artistic expression, and technological innovation, all of it was equivalent to what we possess today. The only thing they lacked was time. The accumulated store of knowledge and technique that we've built up over millennia of trial, error, and transmission. Given sufficient time and the right circumstances, there is no a priori reason why they could not have developed sophisticated civilization. The question we are asking is simply whether they did. There is also a responsibility of intellectual honesty in this inquiry. It requires resisting the temptation to overclaim. The evidence for prior advanced civilization is suggestive, interesting, and in some cases genuinely compelling, but it is not definitive. The honest position is that the hypothesis is plausible, the evidence is intriguing, and the mainstream timeline may be significantly incomplete, but we do not yet have the kind of unambiguous, reproducible, verified evidence that would justify the strong claim that a prior sophisticated civilization definitely existed. At the same time, intellectual honesty requires the same rigor on the other side. Those who dismiss the hypothesis entirely, who refuse to engage seriously with the anomalies we've discussed, who treat the standard timeline as sacrosanct and beyond questioning, they are equally failing the standard of honest inquiry. Science advances by asking uncomfortable questions and following the evidence wherever it leads, not by defending established paradigms regardless of contrary evidence. The honest middle ground is active, rigorous, open-minded investigation. We should be investing serious resources in submerged archaeology. We should be taking the Younger Dryas impact hypothesis seriously and studying its potential effects on pre-existing human populations. We should be using every new tool at our disposal: LiDAR, ancient DNA, refined geological dating, AI-assisted pattern analysis, to look at the deep human past with fresh eyes. And we should be willing to revise our understanding when the evidence demands it. The deepest question. We've been circling around the deepest question in this entire discussion, and it's time to address it directly, not just whether a prior civilization existed, but what it would mean if it did. If it turns out that the story of human civilization on Earth is not a single, linear narrative beginning 12,000 years ago, but a long, complex series of rises and falls spanning perhaps hundreds of thousands of years, what does that tell us about ourselves? What does it tell us about the nature of intelligence, civilization, and progress? And what does it tell us about our chances of survival? The most uncomfortable implication is also the most important one. If advanced civilization has arisen and been destroyed before, it suggests that the creation of sophisticated technology does not automatically lead to survival. It suggests that intelligence and capability, however impressive, do not confer invulnerability. A civilization can reach heights of technical and cultural achievement and still be destroyed by cosmic catastrophe, by environmental collapse, by its own internal contradictions, or by some combination of all three. We are currently a civilization that has developed technologies of unprecedented power: nuclear weapons, genetic engineering, artificial intelligence, geoengineering, with unprecedented speed. We are altering our planet's climate, driving mass extinction, concentrating enormous power in the hands of small groups, and creating systems of technological complexity that no one fully understands or controls. If we are not the first civilization to reach this dangerous threshold, we should be asking ourselves urgently what happened to those that came before. The mythological traditions of the world may contain, encoded in their flood stories and tales of fallen golden ages, a warning that has been passed down through generations of survivors. The warning is simple. We have been here before. Things fell apart. Almost everything was lost. We rebuilt from almost nothing, and now we're here again at another threshold. The question is whether this time we're wise enough to avoid the mistakes that brought down what came before. That is, perhaps, the most practical and most urgent reason to take the question of prior advanced civilization seriously. Not for academic completeness, not for the thrill of mystery, but because understanding our full history, including the parts that were lost, the civilizations that rose and fell, the catastrophes that reset the human story, may be essential to navigating the extraordinary challenges of our own moment. If we are indeed the most recent iteration of a long experiment called intelligent civilization on Earth, then our survival may depend on learning from the failures of the iterations that preceded us. And to do that, we first have to acknowledge that those iterations may have existed. Conclusion: living with the question. We started this journey by imagining standing at the edge of a cliff, looking out at an endless horizon. Now we're at a different kind of edge, not the edge of space, but the edge of time, looking back into the deep past with honest eyes and seeing not the comfortable, familiar story we were told, but something stranger, more complex, more humbling, and more interesting. The question of whether we are the first advanced civilization on Earth cannot be definitively answered with the evidence currently available. What can be said with confidence is this: the standard timeline is incomplete. The evidence that might resolve the question is largely inaccessible. The tools to recover that evidence are only now becoming available. And the importance of the question, to our self-understanding, to our science, and to our survival, is profound. There are things buried under the oceans. There are things buried under the ice. There are things buried under the sands of ancient deserts and the soils of tropical jungles. Some of those things, when we find them, will fit perfectly into the story we already tell. Others, and history suggests this is inevitable, will surprise us, challenge us, and force us to revise what we think we know. The Younger Dryas impact hypothesis, if it is confirmed and its effects are fully understood, may explain a catastrophic discontinuity in the human story that wiped clean an entire chapter of prehistoric sophistication. Ancient DNA will continue to reveal the complexity of our past in ways that no one predicted. Submerged archaeology will eventually illuminate the lost coastal civilizations of the Ice Age, and somewhere, in the rock record, or the ocean floor, or the permafrost of high latitudes, there may be a chemical anomaly, an architectural remnant, or an artifact that changes everything. Until that day, we are left with the question itself, and with the responsibility to take it seriously, not to accept it uncritically, not to build grand theories on fragmentary evidence, but to keep looking, to keep asking, to keep our minds open to the possibility that the human story is longer, stranger, and more remarkable than anything we've yet imagined. Because the most important thing about a question this vast is not the answer, it's what the asking does to you. It humbles you. It makes the world larger. It reminds you that the civilization you live in, for all its wonders, is a temporary and fragile thing, and that the deepest wisdom might be found not in the latest technology, but in the oldest memory, waiting beneath the waves, encoded in myth, inscribed in stone, preserved in the bones of our ancestors, telling us something we very much need to hear. We are not necessarily the first, and that means we do not have to be the last, but only if we're paying attention. Thanks for watching, everyone. If you enjoyed this video, don't forget to like, subscribe, and hit that notification bell so you never miss an update. Drop a comment below with your thoughts. I love hearing from you. Check out more videos on the screen, and I'll see you in the next one. Take care.